Repairing a cord involves ensuring the integrity of its insulation for safety and functionality. It is not advisable to use shrink wrap to repair and sew cord, even if the insulation on the internal wires appears undamaged. Shrink wrap, while useful for bundling and providing some level of protection against abrasion, lacks the necessary electrical insulation properties required for a safe and reliable electrical repair. The primary concern is electrical safety, and sew cord, designed for heavy-duty use and exposure to various environmental conditions, requires robust insulation to prevent electrical shock and fire hazards. The materials used in the original cord are specifically chosen for their dielectric strength, flexibility, and resistance to abrasion, chemicals, and temperature variations. Shrink wrap typically does not meet these stringent requirements. Electrical tape and heat shrink tubing designed for electrical repairs are the recommended alternatives. Electrical tape, such as vinyl electrical tape, is designed to provide insulation, protection from moisture, and resistance to a wide range of temperatures. It is applied in multiple layers, overlapping each layer to create a continuous, insulated barrier. The tape's adhesive is formulated to maintain its bond over time and under varying conditions. Heat shrink tubing is another excellent option. This tubing is made from materials like polyolefin, which offers excellent electrical insulation, flame retardancy, and resistance to chemicals. When heated, the tubing shrinks to conform tightly to the shape of the wire or connector, creating a secure and insulated covering. Heat shrink tubing is available in various sizes and thicknesses to accommodate different wire gauges and applications. When repairing and sew cord, firstly, disconnect the cord from the power source to prevent any accidental electrical shock. Secondly, inspect the cord to determine the extent of the damage. If the insulation on the internal wires is compromised, consider replacing the entire cord rather than attempting a repair. If the damage is limited to the outer jacket and the internal insulation is intact, proceed with the repair using either electrical tape or heat shrink tubing. To use electrical tape, clean the damaged area thoroughly to remove any dirt, grease, or debris. Begin wrapping the tape several inches before the damaged area, overlapping each layer by at least 50%. Stretch the tape slightly as you wrap to ensure a tight and secure bond. Continue wrapping several inches beyond the damaged area. Apply multiple layers of tape to provide adequate insulation and protection. To use heat shrink tubing, select a tube that is slightly larger than the diameter of the cord. Slide the tubing over the damaged area, ensuring that it extends several inches beyond the damage on either side. Use a heat gun to apply heat evenly around the tubing. The tubing will shrink tightly around the cord, creating a secure and insulated repair. Be careful not to overheat the tubing, as this can damage it. After completing the repair, inspect the cord carefully to ensure that the insulation is complete and secure. Check for any exposed wires or gaps in the insulation. If any issues are found, repeat the repair process until the cord is properly insulated. It is crucial to adhere to safety standards and best practices when performing electrical repairs. Improperly repaired cords can pose a significant risk of electrical shock, fire, and equipment damage. If you are not comfortable performing the repair yourself, it is best to consult a qualified electrician. Using shrink wrap as a substitute for proper electrical insulation materials can create several potential hazards. Firstly, shrink wrap typically has a lower dielectric strength than electrical tape or heat shrink tubing designed for electrical repairs. This means that it is less effective at preventing electrical current from leaking or arcing, which can lead to electrical shock. Secondly, shrink wrap is often less resistant to heat and chemicals than materials designed for electrical insulation. This can cause the shrink wrap to degrade over time, especially in harsh environments, leading to a loss of insulation and an increased risk of electrical hazards. Thirdly, shrink wrap is generally less flexible than electrical tape or heat shrink tubing. This can make it difficult to create a tight and secure seal around the cord, especially in areas where the cord is bent or flexed. Gaps in the insulation can allow moisture and contaminants to enter, leading to corrosion and further damage to the cord. In addition to using the correct materials, it is also important to follow proper repair techniques. This includes properly cleaning the damaged area, applying the insulation in multiple layers, and ensuring that the insulation extends beyond the damaged area on either side. It is also important to avoid overstretching the electrical tape, as this can reduce its effectiveness. When using heat shrink tubing, be sure to apply heat evenly and avoid overheating the tubing. The National Electrical Code, or NEC, provides guidelines and requirements for electrical installations and repairs. While the NEC does not specifically address the repair of SO cords, it does provide general requirements for electrical insulation and safety. Adhering to these requirements is essential to ensure that electrical repairs are performed safely and correctly. Always consult the latest edition of the NEC and any applicable local codes before performing any electrical work. In summary, while shrink wrap may seem like a convenient and easy-to-use material for repairing an SO cord, it is not a suitable substitute for electrical tape or heat shrink tubing designed for electrical repairs. Using the correct materials and following proper repair techniques are essential to ensure the safety and functionality of the repaired cord. When in doubt, consult a qualified electrician. Furthermore, understanding the specifics of SO cords is beneficial. SO cord stands for Service Outdoor Cord and is a type of flexible electrical power cord. The letters indicate specific properties of the cord. The S indicates that it is a service cord rated for 600 volts. The O indicates that it has an oil-resistant jacket. The OO indicates that both the jacket and the insulation of the inner conductors are oil-resistant. In addition to SO cords, there are other types of flexible cords, each with its own set of properties and applications. These include SCO, SCENT, STO, SJ, SJO, and others. It is important to select the correct type of cord for the application to ensure safety and performance. The gauge of the wires within the cord is also important. The gauge indicates the size of the wire and its current carrying capacity. The correct gauge wire must be selected based on the current requirements of the appliance or equipment that the cord will be used with. Using a wire that is too small can lead to overheating, voltage drop, and even fire. The ampacity of a conductor, which is the current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating, is governed by the NEC. Tables such as NEC Table 310.15b16 provide ampacity ratings for various conductor sizes and insulation types. When repairing or replacing an SO cord, be sure to select a cord with the correct gauge wire and ampacity for the application. Understanding voltage drop is also essential for ensuring the proper performance of electrical equipment. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 5% for branch circuits and feeders. To minimize voltage drop, use larger gauge wires and keep the length of the cord as short as possible. Additionally, when making electrical connections, ensure that they are clean and tight. Loose or corroded connections can increase resistance and contribute to voltage drop. Use appropriate connectors and terminals for the wire size and application. When connecting wires, follow proper wiring techniques such as twisting the wires together tightly and using wire connectors to ensure a secure connection. Avoid using methods such as simply wrapping the wires together and covering them with tape, as these methods can be unreliable and unsafe. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Ensure that all electrical equipment is properly grounded in accordance with the NEC. Use appropriate grounding conductors and grounding connectors. Test the grounding system to ensure that it is functioning properly. Regular maintenance and inspection of electrical cords and equipment are essential for preventing electrical hazards. Inspect cords for damage such as cuts, cracks, or fraying. Replace damaged cords immediately. Check for loose connections or signs of overheating. Clean electrical equipment regularly to remove dust and debris, which can contribute to overheating. By following these guidelines and best practices, electrical repairs can be performed safely and effectively. Always prioritize safety and consult a qualified electrician when in doubt. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. Remember that working with electricity requires knowledge, skill, and a commitment to safety. Never attempt electrical work that you are not qualified to perform. If you are unsure about any aspect of electrical repair, seek the advice of a qualified electrician.